Next up, I'm gonna show you how to solve the ALEKS problem, identify the better solvent. So what ALEKS is gonna do here is it's gonna show us a solute, and then it's gonna show us two solvent choices, and it wants us to identify which one is the better solvent. So here I kind of have two examples of two different kinds to better kind of go through the lesson and show you. And then my pro tips for this one is that polar solutes want polar solvents, and nonpolar solutes want nonpolar solvents. And remember that diatomic elements are nonpolar. So if you see something such as iodine 2 or oxygen 2 or whatnot, just know that those are nonpolar. And then short molecules make better, or yeah, shorter molecules make for better solvents when it comes to polarity and whatnot. So let's look at the first one. We see that we have NH4 and NO3, and we want to identify which one is the better solvent. So I see that both of them, we do have a oxygen and nitrogen, which shows that they're both dipole-dipole. But what we want to kind of pay attention to next is the size of the compound. So we see that here that the NH, or the N, along with all these carbons and hydrogens attached, are going to be kind of a larger force versus this oxygen with two hydrogens. So pretty much water is going to be more polar as you picture it. Next up, we have this kind of NH4, or I should just call this real name, just ammonium or whatnot, and bromine. And again, we know that this is a like polar compound, and what we want to do is look at our two choices. We see that this is nonpolar because it's all carbons and hydrogen. And then we look here and we see that we have some polarity right here with this oxygen. So because of that, and this being polar, this is going to make for the better solvent. Next up, we're going to deal with calcium chloride. And so we see that we have two choices. One with pretty much a methyl attached to hydroxide, and then we have a carbon attached to 4 chlorines. So what I want you to think is that this right here is a electrolyte. So if you need to go look it up from Gen Chem, you can look, but it's kind of a metal, non-metal, and whatnot. And so we know that electrolytes easily dissolve in like polar compounds, specifically water per se, but not so much when it comes to non-polar. So we see kind of, a polar molecule right here, but then we'll look at the CCl4, and unless you really know, if this is your first time looking at it, you'll probably think, okay, you got a carbon and chlorine, that's going to be kind of polar, but in this case, you have 4 chlorines. So I kind of want you to picture it like this, or you could draw it how you want to, but this carbon has a chlorine right there up top, so I'll put it there. You have, of course, a chlorine off to the side, whatnot. Then you have one, and I'll just draw like the dashes for it. You have another chlorine that's coming at you on the screen. And then I'll draw kind of a dash, which is going to be another chlorine off the screen. So when you have kind of this formation, it's pretty much pulling the dipole in 4 different directions. So it's going to be considered a non-polar compound. So in this case, because this is non-polar and this is polar, we're going to go with the methyl hydroxyl up here. Next up, we have oxygen, and that's attached onto NH2 carbons and H2N, and then kind of our rule is still the same. We see we have oxygen and nitrogen, both that are like kind of, non-polar in their ways, but remember that oxygen, one, is more electronegativity and more polar, and then also it's a smaller compound because you're only dealing with these versus when you got these 3 ethyl groups right here. So you got 3, so that makes for kind of a larger compound all around. So you want to go with your more polar, smaller molecule here. So I'm going to go here with this oxygen. Next up, you have CH3, CH2, CH4, and we've already kind of broke the rules down here. This is considered non-polar because it has no, oxygen, nitrogen, nothing like that really bring polarity to it. And so we're going to go with the better solvent. It's going to be CCl4 because it's non-polar. And then at the end, we have I2, or iodine, and we see that we have 2 of them. That's going to be non-polar, and the similar rules apply. Water is polar. This CH3, CH2, CH3 is going to be non-polar, so that's going to make for the better solvent for that. Again, for this one, you kind of have to go back and refresh yourself on Gen Chem 2 knowledge of what's considered polar, was non-polar, and from there, that'll help guide you through the question. But as you picture some of these molecules in space, such as this carbon or the carbon and the chlorines right here, just picture or draw them out and just picture the way that the dipoles are going and why they're going to be considered non-polar. Again, if this helped you or your classmates, feel free to like, share, and subscribe. Thank you.